Yes.
Okay, we have a visitor.
Hi, we have
Yeah. Hello, Mr. Kirby.
nice to meet you.
Nice to meet you
Oh, you,
too.
you know my work.
Absolutely.
Oh,
I'm a huge fan.
I'm a big fan of it as well.
Thank you.
Um,
It's just Doctor.
my doctor. Yeah, I'll be listening.
Professor Wolfson's my father.
Okay. Come on, I'm Sanjeev.
Thank you.
I'm gonna take you to dinner. Any dietary restrictions?
No dietary restrictions, no allergies whatsoever.
And Indian food, okay?
Yep.
That's very cool. So it's one of the choices, I'll check.
That's right.
You Yes. Yeah. No, actually, done this. I've taken a seminar. Whatever's happening that day, I come in.
Yeah, that's great.
Remember for next time.
All right, let's get started. I'm very happy to introduce Tomer. He comes from originally Tel Aviv University, doing a lot of great work in QA and natural language understanding. And he had a prestigious postdoc award from both CHE from Israel in order to come study now in Dan Roth's group just up the train, UPenn. And I was quite excited by this particular paper, MoNaCo. He's done in collaboration with AI2 when it was even in pre-release. And I was glad to invite Tomer down to talk about it. Please take it.
Right. Thank you. Thank you, Ben. I'm really excited to be here. So I want to make this talk as interactive as possible. So hopefully if you have any questions, feel free to jump in and ask. Also leave time for questions. And yeah, I'll be presenting our work, MoNaCo, natural questions for deep reasoning across dozens of documents. This is work done with researchers from AI2, Tel Aviv University, Bar-Ilan University, and also, of course, from Penn, where I'm doing my postdoc. And it has been accepted to tackle, so it is set to appear in tackle in the next few months. Okay, so let's start with information seeking QA and specifically LLM agents for information seeking QA. So LLMs, LLM powered agents, systems, deep research systems, they're becoming increasingly more ingrained into the way that users and people just query and access information. I was at a dinner party a few weeks ago, and our friend's dad, who's a doctor, told us that people in his clinic, some of his colleagues were actually asking an AI about potential diagnosis for patients, which is a bit scary. But on the other hand, it just shows us how prevalent AI is becoming when people are querying information. So a very important set of questions are questions, information seeking questions are required to synthesize information across dozens or even hundreds of different documents or web pages. However, these types of questions are actually sorely missing from existing AI benchmarks when we try to benchmark the performance of these systems. And personally, I really like this figure. It's from a recent paper called Wide Search by the ByteDance company. And they try to categorize different information-seeking tasks based on how broad the task is in terms of the information sources, and also how deep it is in terms of the number of reasoning steps that it requires. So on the one side of the spectrum, we have benchmarks like BrowseComp and Humanity's Last Exam, both of which are extremely popular in benchmarking deep research systems nowadays. And these are more of the deep reasoning benchmarks where you need to perform multiple filtering steps. Here are two examples from each data set. So in the BrowseComp example, we're interested in a fictional character that breaks the fourth wall, has a certain backstory that involves some things, and is from a TV show that aired between the 60s and 80s with fewer than 50 episodes. Obviously, we're all dying to know what the answer is, but this is a question that has multiple filtering steps, it's hard to find information, but the information to answer this question is actually, I think, in just two separate web pages. So not very broad in terms of the number of sources that you need in order to synthesize an answer. And the same goes for the humanities last exam question about the bone structure of a certain type of bird. So the information is, I think, in just in a single web page, but it is hard to find information. It is less likely that the model has memorized these facts as part of its pre-training data, but it's more about the depth than the broad scope of the questions.
Quick question.
Yes.
The second question there, you said the answer is in a web page. Does it require a bunch of reasoning to get it out of the web page?
It's more about the difficulty of retrieving the correct web page. So it's more about the search, the hard to find information.
Okay. But it's not like a sesamoid bone is the way that it would be referred to in
Yeah.
the web page.
Yes, most likely.
So in some sense, I don't know this particular exam, but you're saying that the way that question is worded is simple retrieval will not get you the document. That's why it's hard.
Yeah, you need to sweat a bit to retrieve the correct pieces of information.
Once you have that document in the
It's
context,
solved.
generate the answer.
It's just so very straightforward. No additional reasoning steps required. On the other side of the spectrum, wide search introduces wide search. So these are questions that do not require a particularly large amount of reasoning steps. They're not particularly hard to find pieces of information, but you do need to synthesize together multiple pieces of information in a factual and structured way, in this case, in a table. So an example question from wide search, we have 6 different Hollywood actresses, and we want all of their film roles between the years of 2010 and 2020. So I think it's spread across just 6 IMDb tables in total, but it's still about retrieving multiple pieces of information. Now, what I think is even more interesting when we're trying to evaluate LLM agents for information-seeking tasks are questions that require both multiple reasoning steps and a broad set of documents to synthesize the answer. Just to give you an example, here's a question that asks, in EU countries, do right-wing political parties tend to favor women leaders more than left-wing parties? Now, you might correctly guess that the answer is no. It is more likely for a left-wing party to be led by a woman, and you'll be correct. But what we would like an ideal LLM agent to give us is not just the final answer. We would like an answer that is fully supported by multiple trusted sources, and we would like an explanation, a high-level explanation that says why the answer is no. For example, overall, there are 46 women leaders of political parties in the EU member states, of which 28 belong to left or center-left political parties, everything with references to the correct, to accurate and reliable sources. This is an ideal answer, I think. And more than that, to solve this question, you would actually need to go over, to exhaustively solve this question, you would need to go over each of the EU member states, review all the political parties currently represented in each of their parliaments, and extract the leaders' gender and their political affiliation. Group them together, aggregate the information, and compare the two scores between right-wing parties and left-wing parties that are women-led. So overall, it involves multiple reasoning steps that include aggregation, filtering, and it also spans across more than 700 distinct Wikipedia pages when you restrict your information source to being Wikipedia. And this is actually a question for MoNaCo, and these are exactly the type of questions that we have in MoNaCo, maybe in slightly smaller scale, but this is the type of questions that we're after. Deep reasoning and a broad set of documents. So just to give you a few examples, MoNaCo questions span dozens and at times even hundreds of documents. We have here the question that we saw before about women-led political parties in Europe. And also we have a question about the percentage of US Supreme Court justices throughout history that did not attend an Ivy League school for their postgraduate degree. So this spans across 59 distinct wiki pages. And again, all of the questions in MoNaCo are can be answered given information that is found in Wikipedia, which is kind of a blessing and a curse. On the one hand, since the information is present in Wikipedia, models have extensively been pre-trained in Wikipedia, so they can a lot of the times rely on their parametric knowledge to solve these types of questions. On the other hand, we can see that when we inject a retrieval component into our experiments, it does not necessarily help results. It can actually degrade performance, which I think sheds a bit of light on the generalizability aspect of these types of questions to potentially other domains that are not in Wikipedia. And we'll see a few examples of this in the end of the talk. So overall, MoNaCo has 1,315 time-consuming questions with an average of 43 distinct Wikipedia pages as the evidence for each question. And standing for more natural and complex question answering, I would highlight that we did put a lot of emphasis that the questions in MoNaCo would aim at reflecting what real world users that are after information seeking objectives would ask for. And I'll touch upon how did we try to mimic that, to make the questions more natural or more ecologically valid information seeking goals in a bit. And the answer could be found in either a sentence, table, or list in Wikipedia. So there is this multi-model aspect in terms of reasoning over both tables and just free-form text.
Question.
Yes.
When you say structured and non-structured, do you have scenarios where like you have a hybrid of sometimes some information is extracted from tables and the remaining part of the chain is extracted from non-structured, or like?
Yeah, that's a great question. So absolutely, most of the questions in MoNaCo involve an intermediate step that requires retrieving information from either a table or a list, whereas subsequent steps will often have the remaining pieces of information in sentences. This is not something that's dictated by the way we structure the data set, that just naturally occurs. So yeah, I think a vast majority of the questions do have their intermediate answers spread across both tables and text. And so leading up to this, what I think really sets MoNaCo apart from existing information seeking QA benchmarks is that we don't just provide the answers and supporting evidence to questions. We also provide a gold standard human annotated reasoning chain. And by that, I mean all the intermediate questions and answers that are required in order to solve the full complex question. So we have 1,300 complex questions in the data set, but they derive over 90,000 distinct intermediate QA steps. And all these intermediate steps are also supported by Wikipedia pages where the information is either in tables or sentences. And we did not experiment with evaluating the reasoning chains of frontier models in this paper, but having these gold standard reasoning chains enable you in practice to try and compare the model's reasoning chains to this gold standard human written reasoning chain and see how aligned it is with the two. Now, it doesn't mean that you can't have multiple valid reasoning chains for the same question, but I think it's still interesting to try and do this comparison, see how much does the two overlap. But this is beyond the scope of this particular paper. And talking a bit more about the reasoning chain. So if you remember this piece of information, the more extensive answer and supporting evidence to our example question here, this is actually synthesized using the information in MoNaCo's reasoning chain. And this is what the reasoning chain actually looks like in our work. It is a set of intermediate steps. Here it's structured as a Python program where each step of the program can be either just a natural language question, like we see here in step number 1, which is which countries are part of Europe. A step can be a step which derives multiple natural language questions based on the answers to previous steps, like step number 2 here, which is which political parties are represented in the parliament of every answer to the first step. So this is actually a step that derives questions like which political parties are represented in the Parliament of Albania, in the Parliament of Bosnia, of Cyprus, etc. And the last type of steps are just discrete query operators that either filter a result of previous steps or perform aggregation like count here, or some arithmetic computation like computing a percentage. So just to give you a shorter example for what this filtering step might do. So in step number 4, we are basically asked to filter the results of step number 2, which is all the political parties represented in the parliament of a certain country, where the result of step number 3, which is the political party affiliation of a certain party, whether it's positioned to the political right, left, or none of the above, and to see whether the political affiliation contains the word right. So this is actually a Python program, very simple Python program that can be executed automatically. We don't need an LLM to run this. We can just implement it using an execution engine, which, spoiler, we did. So this is what we talk about when we're referring to a reasoning chain in the context of this work. And of course, each reasoning chain, at least each QA or QA derivation step, comes with all the relevant information from Wikipedia, the supporting evidence. In this case, over 700 wiki pages, distinct wiki pages. And you might ask, is MoNaCo even challenging? So we evaluated 15 frontier LLMs on MoNaCo, and the best result was by O3 that was able to perfectly solve just less than 39% of all questions. So this is about a perfect accuracy score. And when we use a bit of a more lenient score, in this case F1, and look at the trend of different models, best performing models across the question complexity, we can see that as the number of supporting wiki pages for each question increases, I mean, when we have questions that require more evidence to solve, all models experience a sharp decrease in their F1 scores. The top performing models are GPT-5 and O3, which is not very surprising, and Gemini 2.5 not far behind. So even if we look at F1 scores, we can see that there are definitely challenging questions in MoNaCo, questions that when they require dozens of different wiki pages, they're still challenging to the models, at least in a closed book setting. And we'll see later on the talk that retrieval does not necessarily help for these questions. Yes, any questions?
Yeah. So are the answers to these questions like not ambiguous, but kind of flexible in how in their syntax? Like,
yeah, so that's a great question. We did place a lot of emphasis to try and discard ambiguous questions during our data collection process. Obviously, a major component of ambiguity is time dependence, and MoNaCo has time-dependent questions. However, we do label time-dependent questions in advance, so it should age more gracefully over time than, let's say, other information-seeking QA benchmarks. Yes.
Can you go back to slide 13 while we're on the topic? I was going to save this for later, but since we're talking about it.
Yes, let's go to slide 13. Yes.
Great. Oh,
14?
or-
Okay, here.
It says 13 in the corner. I don't know.
Yeah, you're right. Absolutely.
So it seems to me that all of these are like ambiguous in various ways if you need to interpret them precisely. So a lot of the problem in doing research, and these questions are like somewhere between question answering and the systems that people are building now for scientific research, where they have to do data analysis. A lot of the difficulty in doing research is in operationalizing the questions. So when you say what percentage throughout history, if somebody served on the Supreme Court for 20 years, and somebody else served for only 2 years, do I rate the first one 10 times as much? Because when I say percentage through history, is it percentage of justice, comma, time? Or is it percentage of justice where justice equally? And there's also questions when you say headed by women. Well, this is unlikely to make any difference at present in this the answer or much difference at present, but it could be that you're interested in like maybe somebody isn't permanently a woman, they transition at some point,
Yeah, and you can even mention that, well, if the parties has two co-leaders,
Or
would you
co-leaders.
would you count it as being headed by a woman if one of the leaders is a woman and the other is not?
Great example.
So
Then also a question of, do you weight the parties by size? How do you operationalize left versus right wing? And this is why research is hard. And somewhere, the system is gonna have to make decisions about these. So I'm sure you've thought about all of this.
yeah, so these are all very, very valid critiques. And
It's not a critique, it's just like, it comes with the territory. It's something that the system has to deal with.
right,
It might be a critique of an evaluation because like the system might do something reasonable and yet it's different from what the human would do.
That's absolutely true. And one of the nice, well, and again, we present in MoNaCo a single gold standard reasoning chain for each question. So the reasoning chain is unambiguous based on the interpretation of the expert that's written that chain. And one of the nice properties in terms of disambiguating these questions of the deep research systems, which we did not evaluate in this work, but that systems like Gemini and OpenAI Deep Research ask clarification questions a lot of the time. And then you can disambiguate the questions based on these clarifying questions and hopefully still use this as an evaluation benchmark for the unambiguous setting. I do agree that if the interpretation of the user is different from the one that we have, it might be less of an ideal fit. But I think it's still interesting in the aspect that the information synthesis aspect. And I think it's fair to assume that you can disambiguate many of the ambiguous questions. Right?
I think my own take on this is when I ask a question like this, I don't actually know what I want. And I don't know whether it matters to make it precise or not. And so I kind of want the system to go and say, okay, well, here's the straightforward answer. But I considered what would happen if you asked this question differently. And it actually does make a difference in this case, so I'm letting you know about it.
I see. Okay, my approach would have been to disambiguate the question and then try and solve it based on the user's original intent. But again,
I always have an intent.
Mhm.
Like I have some vague question about whether these things are correlated.
Nice.
And if the answer depends, it would be nice if the smart system could actually figure that out.
That's completely valid. I agree. But I think our perspective on this was more of like a database reasoning style question over text, where someone is very confident on what they're looking for. It's
Right, as distinct from the research question.
yeah,
Yeah, okay, thanks for indulging in that question.
but absolutely a valid and very realistic point to bring up. Let's see.
One question,
Yes.
back to the graph where you would stop. Yeah.
This is jumping all over the place. I'm sorry.
Yeah.
Yeah.
This one, right? So the downward trend is sort of understandable in this one's intuition says it should happen. The mid-30s to 40s performance on the large one is new knowledge. I didn't know how bad it could be.
Mhm.
I don't, if you have time now or later, tell us why when you have only 1 or 2 pages containing the information, they're still in the low 60s to low 70s.
Because this is a closed book setting. So the model is using nothing but its parametric knowledge to solve this.
Right.
So, yeah. And I think, again, if you're dealing with a small number of web pages, if you give it access to a retriever, it will probably work better. If you're dealing with dozens of web pages that you need to retrieve in order to synthesize the answer, then stuff gets murky. Yeah.
I think it is like Sanju said, it is expected that the trends are going down. I think what's quite compelling is that when your questions require 70 pages of Wikipedia, these models are still getting more than 40%. In certain cases, O3 is getting close to 60%,
Right.
which is quite remarkable. Can it be that the way you are measuring the 70 pages as is perhaps not very accurate as possible, that someone has already done the work for you on the internet, that they have already done the summarization for you, and the models kind of get to see the aggregate results somewhere? Or is it truly that like the information is actually distributed across 70 pages and they're doing some remarkable reasoning to get 60%?
No, that's completely possible that there are reasoning shortcuts, like with the example of the left versus right-wing women-led parties. Again, it's a lot easier for them to guess the correct answer, which is no. But for that, you can actually try and test them on all the intermediate questions. So instead of they're able to say whether the answer is yes or no on this question, but can they tell me correctly what is the number of women left-wing political parties in EU countries, which is an intermediate question in this reasoning chain, which we have the answer to. We just didn't do it in this paper. So I think to combat reasoning shortcuts, you can definitely try and evaluate models on intermediate reasoning steps and see whether their performance remains the same. Because a person that's able to answer the complete question without a reasoning shortcut would also be able to answer all the intermediate steps, the very high accuracy. For models, that might not necessarily be the case because of reasoning shortcuts. Okay. So, how did we build MoNaCo? So to build MoNaCo, we needed two things. The first was good questions, good information-seeking questions. And by good, I mean questions that are realistic in the sense that they hopefully reflect the information-seeking goals of a real-world user of some sort. And the questions should also be time-consuming, so that cannot be answered without synthesizing together hundreds or dozens of intermediate computation steps or web pages. So this aspect of deep reasoning or a broad set of documents kind of translates to this time-consuming aspect. And the second thing that we need to do once we got these good questions was to annotate them with their answers and all their supporting evidence from Wikipedia. So let's start with the question collection task. So what we did was use Mechanical Turk crowd workers, and we tried to prompt the workers into writing questions that would interest a particular target persona. So we came up with about five sentence descriptions of 14 diverse personas. We have here a history professor studying wars and military conflicts in France between the 17th and 21st century. We have an amateur chef, a political science student, an assistant professor of theater studies, and we really try to make the workers be more creative in the questions that they come up with. So in these cases, they do come up with relatively good questions like which two noble families did the French Bourbon kings marry into the most? For the political science student, do people in Midwestern U.S. states support same-sex marriage more than in the Deep South? But ultimately, we also provide workers with a set of random keywords related to each persona from a higher keyword bank that is meant to spark more diversity across these different domains. And also we expose them to 5 example questions originally written by us, and later we replaced them with random questions that were good questions written by workers. So this was meant to, the example questions were meant more to make workers think in the direction of the hard questions that we were after, questions that required multiple sources of information, questions that required multiple reasoning steps. But ultimately, it was a very wide process. I think we collected over 8,000 questions from 60 workers, I think, and we ended up with a set of 2,000. So it wasn't a very clean. I can't tell you that it was a very clean and pretty process, but we were after a benchmark here, not a scalable data synthesis approach. So if we ended up with 2,000 good questions, we were happy with that. So we ended up with these questions that span up to hundreds of documents at times. And these questions are just too complex for a single person to answer at a reasonable time. So we got what we wanted, but now we have to figure out how exactly do we solve these questions. And also, even disregarding the comprehensive set of evidence that we want from an annotator, even simple things like computing the average over a set of 10 results, like we want an average age of a Supreme Court justice in the 60s, you got to maybe average, I don't know, 10 different ages. A worker might make an honest mistake. So this is just not a task that's fit for a single person to answer. And our solution was to break it down into multiple, much simpler tasks, basically question decomposition. So, sorry, if you remember this reasoning chain that I showed you before, well, this is not a reasoning chain for modeling purposes. This is a reasoning chain for annotation purposes. This was the tool that we use in order to distribute and simplify the answer annotation task for MoNaCo. Basically, having a preliminary step in which experts that were familiar with our question decomposition syntax from a previous work of ours, also with AI2, called Break It Down, a question understanding benchmark, where it was basically a question decomposition data set. So we had a preliminary steps in which these expert question decomposers, given a question, would give us this list of intermediate steps that were either natural language steps, steps that derive multiple natural language questions, or just discrete query operators. And by having this structure, it enabled us to simplify the answer annotation task, basically deriving follow-up questions based on the answers to previous steps, or in the case of discrete query operator steps, just execute the script automatically, like we saw with this filtering step. We had a query execution engine that we built that did all that supported over 31 query operators, supporting most of the SQL query operators, if any of you is familiar with SQL query language. So filtering, aggregation, grouping, all that was supported by it's still supported by execution engine. Okay, so we collected the questions, then we asked crowd workers to break down the questions, giving us a reasoning chain, a solution to solve this question, given the information in Wikipedia. And based on the answers to the intermediate questions, like over here, we can see what are the Midwestern US states, and we get a list of answers. We can basically assign these answers to follow-up steps, deriving multiple follow-up intermediate questions, like what is the percentage of people in Iowa that support same-sex marriage? What is the percentage of people in Kansas that supports same-sex marriage? Distribute the annotation task, basically issue these intermediate follow-up questions to different crowd workers, get the annotations, and another nice byproduct of this is that certain answers can be found in a wiki table, like the answer to step number 1 here. Others are in a paragraph of text, and we basically get questions with a large set of supporting evidence. And finally, for query operator steps, in that case, we just use our execution engine that we built to compute average or compare two numbers automatically, avoiding any manual honest mistakes on these types of discrete query operator steps. And that is how we got the final answers to MoNaCo questions. Yes.
Did I understand this correctly that you decompose questions independent at a separate step than actually annotating the answers to those intermediate steps?
Yeah,
in which case, would there be any concerns about it, like the need to have certain decomposition, like the knowledge that you have impacts what kind of decompositions you need, right? Like if the knowledge is more distributed in different places, perhaps you need more granular decomposition, or perhaps if there's a page that already has a more aggregated answer, perhaps you need less decomposition.
That's 100% correct. I mean, the structure of the decomposition is dependent entirely on the structure of the data source, of the information source. If we just had in Wikipedia a single sentence that said people in Midwestern US states support same-sex marriage more than in Deep South, you don't need to decompose it at all. It's there. Which is why we, when the workers gave us the decompositions, we also instructed them to be aware whether or not these intermediate questions were solvable given Wikipedia, which, again, these are crowd workers. They might not account for that. So we also did a second step of just reviewing all these question decompositions manually, and we ended up correcting around 15% of them and discarding some examples where the information was not given was not present in Wikipedia. So we either needed to change the decomposition a bit or just discard the example altogether. But for the vast majority of examples, it was answerable given Wikipedia evidence. Yeah. Yes.
So I think this is related to my earlier question, but it comes out as a real issue in this one. Now, questions 2 and 5 might give incomparable answers because the question was asked, that percentage was determined differently. So you have a crowd worker who's looking at a particular poll, and you're a different crowd worker who's looking at a different poll that phrased the question a different way or had a different sample of subjects.
That's true. That's where the supporting evidence comes into play. But again,
There's nothing here, I think, in this workflow that requires step 7 to make any adjustments.
yeah, that is true. That is true. It's even I'd say that there is also an ambiguity in the question in the sense that percentage. Are you looking at the normalized percentage based on the population size, or are you just looking at the percentage itself? Does that mean that this solves it? That is true. There is a certain level of ambiguity in terms of the information source and in terms of the reasoning chain itself that's baked into this. This is not super prevalent, I think, in other questions, but again, this is a valid concern.
Yeah, there's a specific about comparison.
Yeah.
Maybe don't show up.
I think what we do in terms of that is just to provide the exact evidence that this is based on. So at least someone that's interested in invalidating this in a rigorous manner, they can trace it exactly to the Wikipedia table where the information is stored and try and see where it is and what is the actual source that presents this fact. True. Any other questions before we move on? Yes.
The first step, how do you filter out the additional 8,000 questions to the 1,000 question? Or I'm curious, like, how would you define a good question that made it?
So we wanted questions that span across multiple documents, that involve multiple reasoning steps and make sense, I'd say. So if we look at the browse comp example about TV character from a sitcom between the 60s and 80s with fewer than 50 episodes, that I would not consider to be a valid question because it comes off more as like a trivia question when the person asking the question is already familiar with the answer. So this was one of our criteria for disqualifying worker questions. Okay. So this was the way that we built MoNaCo. Now just a few nice statistics about the data. It has over 1,300 complex questions, but these complex questions have intermediate QA steps, which are actually, we have over 90,000 of these intermediate QA steps. And when we look at, and these 90,000 intermediate QA steps have evidence from over 36,000 distinct Wikipedia pages. So the information is covered that's covered by MoNaCo question is relatively diverse, I'd say, in the number of topics that is covered. And also when we look at the intermediate question types, list question answering questions where the answer is a set of answers actually was quite popular, I think, 2 or 3 years ago. And the leading benchmarks in that area, like Comparing Quest, had between 2,000 to 3,500 human written list questions. MoNaCo has over 8,500, so it's the largest of human written list questions benchmark that I am familiar with. And the same also goes for yes/no questions, Boolean questions. Over 40,000 of the intermediate questions in MoNaCo are yes/no questions, which is significantly higher than previous Bull QA benchmarks like Bull Q and Strategy QA. And just when we look at the average number of Wikipedia evidence pages, average number of intermediate questions, intermediate answers per question in MoNaCo, these numbers are significantly higher than in widely used information seeking QA benchmarks out there. The full results are in our paper, but just something to bear in mind. And a valid thing that one might ask, I don't want to waste too much time on this, but are these even natural questions? So I told you we put a lot of emphasis on making MoNaCo questions reflective of a real world user information seeking goal? Does it make them natural? This is something that we were after. Originally, we wanted a benchmark of complex reasoning, but also that the questions would be perceived at least as natural as existing natural QA benchmarks, like, for example, Google Natural Questions, which is very natural, considering the fact that its questions are taken directly from real world users. Search queries even might be your own search queries if you issued stuff to Google that was answerable given Wikipedia in 2017, 2018. So we wanted to compare ourselves with existing natural QA benchmarks and basically rank how MoNaCo questions were, how natural were MoNaCo questions perceived when compared to these other benchmarks. And we compared ourselves to 8 different QA benchmarks, 4 of which were natural questions benchmarks and 4 of which were artificially or semi-artificially generated. And our criteria were, we had 2 criteria for basically ranking the questions. The first was for a participant in our user study to determine who is the most likely to have written this question out of an expert user, a regular user, or a machine rule-based script. So this is not an AI, this is a rule-based script. And the second criteria, which is a bit more tricky, was to assign a score between 1 to 5 based on how likely is the person asking the question already familiar with its answer. And that was to counter questions like the ones that we just saw in BrowseComp. Fictional character breaks the fourth wall, has certain backstory, TV show between 60s and 80s with fewer than 50 episodes, where this question, I would say, does not represent an information-seeking goal of someone that doesn't know the answer. This is actually a question that's meant to test the capabilities of an information-seeking question. It's more of a trivia question, to be honest. Exactly. So the person asking this question is obviously familiar with the answer. A lot of real-world users are after information that they don't know in advance. So this is more of what we were after when referring to natural information-seeking goals. These are more trivia goals. And our user study, we had 18 participants, none of the paper authors, naturally. And MoNaCo questions were ranked much closer to the natural QA benchmarks in blue than to the artificial and semi-artificial QA benchmarks in orange on both of these criteria. And when asked to measure who is the most likely writer of the question, well, unsurprisingly, natural questions is the most natural was considered the most natural QA benchmark, with just 7% of its question being referred to as written by a machine rule-based script. However, MoNaCo was ranked as having the most expert written questions as perceived by the user study participants, which is also nice, I'd say. At least things align with what we expected them to be. Okay, so this is about the natural aspect of questions. And if there aren't any questions, let's move on. Let's move on to the actual experiments. So the fact that MoNaCo has this breadth of supporting evidence and multiple reasoning steps, it actually makes it an ideal LM benchmark in a number of different settings, some of which we did not evaluate in this paper, but 3 of which we did. So one is basically to evaluate models' parametric knowledge and reasoning. These questions require information from Wikipedia, which the model has seen in its pre-training phase. So that's kind of the blessing of the usage of Wikipedia data. And they require a lot of times combining the information that this model has seen and aggregating over it. So this is the reasoning component. Also, we can evaluate MoNaCo in a long context setting, basically concatenating all the goal documents that we collected to the model's context and see how well does it solve the question when all the information is just provided in its context. And most questions in MoNaCo require multiple web pages that contain the information. So we said 43 distinct Wikipedia web pages on average per query. This can serve as a multi-document information retrieval benchmark to test the ability of IR systems. We did not do this in this work. And Another thing was just to evaluate an end-to-end retrieval augmented system, which we did do. And lastly, you can use the reasoning chains in MoNaCo to try and maybe evaluate deep research trajectories, which is something I'm interested in, but not something that we explore in MoNaCo itself. We will see a few nice qualitative results later on, though. And yeah, for answer evaluation, we had GPT 4.1 is our judge, and basically with computer precision and recall, and we had special cases where the answer was a number. So if the answer was a number, we computed a normalized similarity score between the gold number and the predicted number. So if the correct answer is 100 and the model and one model predicted 70, the other model predicted 6. Obviously, the one that predicted 70 would be rewarded much more. And also we had cases where the answer was a list, and in that case we compute precision and recall in a semi-automatic manner. Full details are obviously in the paper. So these are the results that we saw before of the model's performance as a function of the question complexity. And we have here another measure of question complexity. So we have the number of distinct Wikipedia pages that are necessary to answer each question. This is the one that we saw before. We also evaluate performance as the number of intermediate answers that are involved in the computation. So we see a pretty similar trend here in both cases, just based on the number of intermediate answers. The number of distinct Wikipedia pages, models suffer a degraded performance, and still O3 and GPT-5 come on top. So this is a closed book setting. Now, I want to highlight another result here. That's this is just with GPT 4.0 and Llama 3. However, in this experiment, we evaluate the 8,500 list questions of MoNaCo. So these are not full questions. These are intermediate questions that have more than 2 answers. And over these 8,500 questions, we see that both of these models have very good precision. Even as the number of answers per question increases, the precision is maintained, but there is a significant degradation in the recall. Again, this is a closed book setting, and it might be expected, and these are older models. The interesting thing is that low recall remains a problem even in deep research systems like OpenAI, Deep Research Gemini, Deep Research and Perplexity to this day. So while these older models have recall as an issue, this low recall problem does persist into much newer systems, and we'll see that. Yes.
As the number of things you need to find increases, right?
Mhm.
So what I'm wondering is, why should one expect precision, like recall, to not go down?
Because this is not a hard retrieval.
They're not equally
Yeah.
easy things to find, right? So the easy ones will be.
They are equally easy things to find.
They are.
They are, because the workers manage to find these lists themselves. And in fact, in Wikipedia, there is a page titled List of for many of these questions. So MoNaCo is a hard retrieval task if you don't break down the questions. If you break down the questions, each question in isolation is not a very difficult retrieval problem.
Because I was thinking of saying that precision, as soon as there are more answers, it's easier to be right.
Mm-hmm.
So, okay, so you're saying that these are both, in both directions, they're equally easy items to find. It's not like the 500th item is harder to find than
That's true. That's true. The workers managed to find the answers to both cases, both when it was a list question and when it was just a single answer question. And again, many of these lists are part of the model's pre-training data. When we try and evaluate deep research systems over these questions, again, these are answers that are grouped together in a single Wikipedia page. So the information is not particularly hard to find, at least not for MoNaCo questions. Okay. So we also evaluated MoNaCo in an Oracle retrieval setting, which we see here highlighted in green, and we compared it to the closed book setting in blue. And unsurprisingly, we see that both GPT 4.0 and Llama 3.1 experience a significant increase in performance when we provide them with all the requisite information as part of their context. Now, documents here are either chunks of tables or sentences, and also we prepend to each document the title of the document and the title of the subsection. So the model is aware that these are different documents, and it's just not just a scramble of text that they are given. What is the interesting thing, though, is that GPT-4o is far from completely solving this task, even when all the relevant information is provided. So it falls short of even 60% F1, which is worse than the closed book performance of something like GPT-5. While this is not included in the paper, we do have Oracle results of GPT-5 on MoNaCo, and it's of around 75%. So what I took from this was that GPT-4 was not able to reason over documents. It was worse. It was not good at aggregating the information, whereas GPT-5 is capable of doing it. But this is not a rigorous experiment. This is just based on my observation here. And when we compared the closed book setting to a retrieval augmented setting, where we basically retrieve the top 20 Wikipedia documents by a BM25 retriever over Wikipedia, well, we get significantly worse results. We get an 11-point decrease in F1 compared to the closed book setting. You might argue that BM25 is not a great retriever, especially not when you run it over the full MoNaCo question without decomposing it, and you'd be correct. However, these models were instructed in their prompt to ignore any irrelevant information. And since the retrieved documents were all from Wikipedia, there was no false information provided to these models. It was just maybe irrelevant information. So there is still this thing of the models not being robust to irrelevant context. And again, this is something that's also widely discussed when we're talking about context engineering to deep research system. So this is a problem that I think is still present with us. So something to bear in mind. Sometimes not giving anything to the model when it has seen the data in its pre-training is better than giving it irrelevant but accurate information. So retrieval does not always help. I would like to discuss a bit about future directions. So we did discuss maybe using the gold standard reasoning chains in MoNaCo. One way you can use these chains is maybe to synthesize data, because we do have all the intermediate steps with the assignments, and we do have the query execution engine. So maybe it's a good place to start if you want to synthesize these trajectories automatically. And we did not evaluate any deep research systems in our papers. So it turns out that even these state-of-the-art systems sometimes struggle on MoNaCo questions, even though, again, all the evidence to answering these questions is present in Wikipedia. And each of the intermediate questions in isolation is not particularly hard in terms of the retrieval problem that it poses. So just to give you an example, 3 examples that we played with in MoNaCo. Which British prime ministers were known for cheating on their spouses? Both Perplexity Deep Research and OpenAI Deep Research give us incomplete answers. I think they gave us 8 out of 13 answers. And when we look at the running example about women-led political parties in the EU, both these systems answered this question correctly, actually. But when we pose, why this has gone to black? Oh, you can still see my screen. This is just, okay. So when we pose an intermediate question, that is how many left-wing political parties in EU countries currently have a woman leader? Perplexity AI says the answer is 3. OpenAI says 13, and Gemini says 18 parties, whereas the answer, according to the beginning of 2025, was 58. So this is far from perfect recall on this task. And what's even more annoying, I'd say, is that for both Gemini and OpenAI Deep Research, they generate a plan in advance, and they actually ask questions to disambiguate this question. Like, for example, should I refer to parties that are co-led by a woman and person who's not a woman as being women-led? And answer would be yes. And they say the exact same, that they're doing the exact same plan as in MoNaCo's gold reasoning chain. I'm going to go over all the countries, over all the political parties represented in each parliament, and I'm going to extract the the party leader's gender and the political affiliation, group them together, and still they get incomplete results. So something is breaking along the lines. Something here might not be adapting right to questions that require a more broad scope of evidence. That's my suspicion, at least. We need to solidify this. And even in very simple questions, like we have here 3 presidential election campaigns and 3 results by 3 separate polling firms, and we want to find which one of these 3 had the lowest average error according to the most recent poll. Both OpenAI, again, Perplexity is just wrong, but both OpenAI and Gemini Deep Research get the correct answer, which is CNN, but both of them failed to find a single piece of evidence here. So I think CNN fails to find, Gemini fails to find one of the CNN results. OpenAI fails to find one of the New York Times result. They do mention that, but again, this is not hard to find information, which is a bit confusing, I'd say. Okay, just to conclude, we presented here MoNaCo, which is a benchmark of 1,300 complex natural questions that span over 90,000 intermediate QA pairs, complete with evidence from Wikipedia, and we have the question decompositions. We saw how this question decomposition approach enabled us to distribute the annotation of much harder questions, facilitated the annotation task, and also the use of an execution engine facilitated the annotation, the computation of discrete reasoning steps. And overall, we hope that MoNaCo helps in evaluating factual and attributable AI systems, and all of our data is available on Hugging Face. So thank you very much. Yes.
Thank you for the great presentation. So going back to your earlier point that recall is a big challenge here on a broad range of deep research questions. A pessimistic take here is that recall will remain a problem for all the future deep research systems because there's always going to be unknown unknowns. Do you see a more positive, optimistic take here that perhaps there might be a range of problems for which we can provide some sort of guarantees, mathematical or otherwise, on making sure that we have near perfect recall?
I think so. I think even with MoNaCo, the fact that recall is a problem is it's not a real problem. The information is in a hub someplace. There is a single Wikipedia page that contains all this information, and also you have web crawlers that go over a large set of documents and index the web. So I think a lot can be done with pre-indexing and preparing these databases in advance so that models can query it relatively easy at real time. The thing is that a lot of information seeking QA research has been dedicated in these maybe even long horizon questions, but very narrow in terms of the scope or the number of documents that they encompass. So I don't think the architecture or the way that these systems are built is wrong in any way. They just need to be adapted to this setting in the future. So I am optimistic, to be honest. I'm just pinpointing these issues with existing systems. Yeah. Okay. Right. And if you have any questions on the data set or you're interested in using it, feel free to email me. I'm very happy in promoting this in the future. Thank you. Okay.
Great presentation.
Thank you.
Yeah, thanks so much.
I think I'll
You also got a ton of questions.